Well, the population of python in the Everglades has dramatically dropped.
Burmese pythons have devastated native wildlife in the Everglades.
Under the dark, slow waters of Florida's Everglades, a frightening secret has been uncovered. Leaked footage shows a swamp that no one expected, an environment hanging on the edge of disaster.
After arriving here as seemingly innocent pets, these snakes have overrun their new environment in just a few decades. The thing is, there's still a lot we don't know about how these elusive snakes live in the wild.
Giant invasive snakes hiding in the mud and armored catfish digging through the banks are just the start. Predators can be seen, but the real danger is hidden below. Poisoned mud, tiny parasites, and chemicals from the past all threaten the fragile life there. As scientists rush to understand it, the footage asks a scary question. How much of Florida's river of grass can survive when the swamp itself fights back? Join us in this video as we discuss the details. The horrifying discovery revealed from Florida's swamp leaked footage. The Everglades ecosystem has suffered a dramatic and deeply alarming collapse, especially in the southern regions where wildlife once thrived. Researchers monitoring these areas have recorded population losses that are almost impossible to believe. In some core zones, raccoon numbers have fallen by more than 99%. Opossums have nearly vanished, and bobcat populations have been reduced to a fraction of what they once were. These losses did not happen slowly over generations. They occurred rapidly, within just a few years, signaling that something fundamental inside the ecosystem has broken down. One of the strongest pieces of evidence comes from trail cameras placed deep within the wetlands. These cameras are meant to capture normal animal movement, such as mammals feeding, traveling, or hunting. Instead, researchers repeatedly found footage showing nothing but empty grass, shifting shadows, and still water. Hours passed with no visible life. This kind of silence is unnatural in a healthy swamp and points to a system that has been pushed past its limits. The Everglades, once full of sound and motion, now show signs of ecological collapse. For many years, the Burmese python was blamed as the main cause of this disaster. These large snakes are not native to Florida and were introduced mainly through human actions. During the 1990s, Burmese pythons were popular exotic pets. Many owners released them into the wild once the snakes grew too large to handle. In addition, Hurricane Andrew in 1992 destroyed several reptile facilities in South Florida, allowing captive snakes to escape into nearby wetlands. The Everglades offered warm temperatures, water, and abundant food, making it an ideal place for the snakes to survive and reproduce. As the python population grew, their impact on wildlife became obvious. They preyed on mammals, birds, and reptiles that had no natural defense against such a large predator. However, scientists later realized that predation alone could not explain how fast and complete the collapse had been. Even with hundreds of thousands of snakes, the numbers did not fully add up. Something else was accelerating the damage. Further research showed that fear played a major role. Native animals did not just get eaten. Many changed their behavior completely. Mammals reduced their movement, avoided open spaces, and stopped breeding. Some animals hid underground or fled the area entirely. This constant state of fear led to starvation, stress, and reproductive failure. As a result, populations collapsed even in places where animals were not directly consumed by pythons. The ecosystem began to empty itself. While researchers were focused on these visible changes, a hidden threat was spreading unnoticed. Burmese pythons were found to carry a parasitic lungworm called Rhylietiella orientalis. This parasite evolved alongside pythons in Asia, meaning the snakes can carry it without getting sick. The pythons act as silent carriers, spreading the parasite through the environment. Native North American snakes, however, have no natural resistance. When the parasite infects a native snake, it causes severe damage. The worms invade the lungs, feed on tissue and blood, and trigger intense inflammation. As the infection worsens, the snake struggles to breathe and eventually suffocates. Infected snakes are often found with their mouths open, desperately gasping for air. In some cases, the worms are visible emerging from the mouth during the final stages of infection. The parasite spreads through a simple but efficient cycle. Python waste releases parasite eggs into the environment. Insects feed on the waste, amphibians eat the insects, and native snakes become infected when they eat the amphibians. Once inside the snake, the parasite migrates to the lungs and continues its life cycle. This process allows the parasite to spread without direct contact between snakes. Most concerning is the fact that the parasite no longer depends on Burmese pythons to survive. While the snakes remain mostly limited to South Florida due to cold temperatures, the parasite has already been found far north of the python range, including near Jacksonville. This means that even if pythons were removed, the parasite could continue spreading through native wildlife. So, after seeing how the Everglades was first pushed into chaos by invasive snakes and unseen parasites, the question now becomes this: how did this hidden threat spread so far beyond the pythons themselves? And why did it turn a controllable problem into a lasting ecological crisis? Let's find out. When the threat moved beyond the snake. The parasites carried by the pythons did not behave like the snakes. Burmese pythons struggle with colder temperatures, which is why their spread has mostly stayed in South Florida. The parasite, however, did not follow those rules. It adapted quickly. It found new hosts. It moved through insects, frogs, and native snakes without needing the python at all. Soon, cases of the same lung damage began appearing far north of where pythons were known to live. This was the moment researchers realized the crisis had entered a new stage. This discovery changed everything. Before, there was at least a sense that the problem could be contained. If the snakes could be hunted, removed, or slowed down, maybe the damage could be stopped. But parasites cannot be hunted. They cannot be trapped. You cannot put a bounty on something that lives inside another animal and spreads quietly through food chains. Once the parasite became independent, the idea of simply fixing the problem disappeared. Scientists were forced to accept a hard truth. Even if every Burmese python vanished overnight, the damage would continue. The parasite was already established. It was already cycling through the ecosystem on its own. Native snakes were still getting infected. Lung tissue was still being destroyed. Animals were still dying without clear signs of attack. The crisis had moved from invasion control to long-term survival. This shift made the situation feel far more urgent and far more hopeless. Traditional wildlife management tools no longer applied. The ecosystem was being attacked from the inside, in ways that were nearly invisible until it was too late. The Everglades was no longer just fighting an invasive predator.
This is the Burmese python. A python of this size would be quite the voracious predator out here in the Everglades. And what people really worry about is these eating some of the more threatened species like American crocodile hatchlings or the key largo wood rat.
It was fighting a biological process that had already spread beyond its point of origin. As this reality set in, discussions among scientists became darker and more serious. The question was no longer how to remove the threat. The question became how to slow the damage enough for anything native to survive. This kind of thinking leads to uncomfortable decisions. When an ecosystem begins collapsing this quickly, normal rules stop applying. Desperation replaces caution. That desperation led to an idea that once would have sounded reckless. If the invasive snakes could not be fully removed, maybe they could be pushed back naturally. Instead of fighting snakes with traps and hunters alone, the state turned to biology itself. The plan was not to erase the damage, but to counterbalance it. This is where the eastern indigo snake entered the story. Long ago, this snake was one of the most powerful native predators in the region. It was large, fearless, and constantly moving. Unlike ambush snakes, indigos actively hunt. They do not avoid danger. They do not rely on venom. They overpower their prey through strength and persistence. Most importantly, they eat other snakes. For years, indigo snakes had been missing from large parts of their former range due to habitat loss and development. Their absence had left a gap in the ecosystem. Now, that gap mattered more than ever. Scientists believed that if indigos could be brought back, they might help control invasive snakes by targeting juveniles before they could grow and reproduce. This decision marked a turning point. It was no longer about restoring the Everglades to what it used to be. It was about preventing further collapse. The focus shifted from recovery to resistance. And with that shift, the Everglades entered a phase where every small success mattered because failure would not come all at once. So the question now is simple. Can native wildlife push back against the damage? Or is it already too late? Resistance, adaptation, and an uncertain future. The reintroduction of the eastern indigo snake was a gamble, and for a long time, no one knew if it was working. Wildlife reintroductions fail often. Animals raised in captivity may not adapt. They may struggle to hunt, they may fall victim to predators or disease. For years, the indigo releases produced no clear answers. The snakes vanished into the landscape, and the swamp remained quiet. Then something happened that changed the tone of the conversation. A trail camera captured an image of a baby indigo snake. This was not a released animal, it was wild-born. That single image meant the snakes were surviving long enough to breed. It meant they were finding food, shelter, and suitable habitat. It was proof that at least one part of the ecosystem was pushing back. At the same time, scientists began noticing changes that had nothing to do with planned intervention. Native predators were behaving differently. Animals that once avoided Burmese pythons at all costs were starting to test them.
Burmese pythons have done unprecedented damage to the ecosystem in South Florida, and experts say these invasive snakes continue to move farther north.
Bobcats were among the first to show this shift. Trail camera footage revealed bobcats approaching python nests, destroying eggs, and even eating them. This was not panic behavior, it was deliberate. More footage followed. Bobcats dragging python carcasses into cover, caching them under leaves and dirt, saving them for later. This kind of behavior shows recognition. It means the animal understands the python as prey, not just a threat. Alligators were also seen ambushing smaller snakes in the water. Reports emerged of Florida panthers attacking juvenile pythons as well. This pattern has a name. Scientists call it biotic resistance. It happens when native species slowly learn how to deal with an invader. It does not happen quickly, and it does not happen evenly. Some species adapt faster than others. Some never adapt at all. But when it works, it can change the direction of an invasion. Still, adaptation has limits. Bobcats cannot remove hundreds of thousands of snakes. Indigo snakes are still few in number. The parasite continues spreading quietly, unaffected by claws or teeth. What exists now is not a victory, but a fragile line of defense. One that could either strengthen or collapse, depending on timing, climate, and chance. The Everglades has effectively split into two different realities. In the south, the damage is deep. Mammals are rare. Native snakes are failing. The parasite is well established. These areas are not recovering. They are stabilizing at a lower, broken version of what they once were. Life exists, but it is reduced, altered, and quieter. In the north, the outcome is still uncertain. Indigo snakes are settling in. Native predators are learning. Resistance is forming, but it is thin and vulnerable. Whether it will be enough is still unknown. This makes the current moment critical. If resistance grows faster than the damage spreads, the collapse might slow. If not, the silence will continue moving north. One thing is already clear: the Everglades will never return to its original state on its own. Ecosystems do not rewind. Species that vanished are unlikely to come back without help. Behavioral changes caused by fear and pressure may last for generations. Animals growing up in this environment will inherit a world where caution replaces abundance and silence replaces noise. What is happening in the Everglades is no longer just a local issue. It is a warning. It shows how invasive species, hidden parasites, and human actions can push ecosystems past points where simple fixes work. It shows how damage can continue even after the original threat fades from view. The swamp is not dead. It is changing, and that change is happening under pressure through loss, adaptation, and conflict. The future Everglades will be shaped by what survives this phase. Not the strongest species, but the ones that learn fastest. The ones that adjust before the rules change again. The silence that started this story was not the end. It was the signal that something deeper had already shifted. While the struggle between invasive predators and returning native species unfolds above the water, what secrets lie hidden beneath the mud when the Everglades itself is drained? Let's delve deeper. The Everglades and its hidden world. The Florida Everglades is a very big, very slow river that people often call the River of Grass. It is not just a river, it is a huge wetland that spreads across millions of acres of land. The Everglades is very important because it acts like a natural filter. It cleans the water that moves through South Florida, but over the last 100 years or more, humans have changed it a lot. People have built canals, pumped water, drained parts of it, and made land for farms and houses. All these changes have made it very hard for the plants and animals that lived there naturally. A long time ago, in the 1880s, a man named Hamilton Diston decided to drain a lot of the Everglades. He wanted to make land for farming. He spent a lot of money and moved millions of gallons of water out of the CM River basin. Later, in 1948, the government built a huge system of canals and pumps. This system was called the Central and Southern Florida Project. It was supposed to stop floods and give water to people, but it also destroyed more than half of the original wetlands. Because of this, many animals and plants had to find new ways to live. They had to adapt to a place that was very different from before. Today, people are trying to fix some of the damage. They have built places called storm water treatment areas. These are man-made wetlands that cover tens of thousands of acres. Scientists use them to clean water before it goes back into the Everglades. Sometimes they need to drain these areas to clean the mud or fix the plants. When the water is drained, it reveals what has been hiding under the surface. Biologists go out there expecting to see just a few fish or maybe some trash, but what they often see is much bigger and much more surprising. In one recent project, they saw thousands of fish trapped in tiny pools of water. Some of these fish were native, like largemouth bass and bluegill, but many of them were invasive, like armored catfish. These catfish have hard, bony plates on their bodies that protect them. They can dig into the mud and live in burrows that are hard to see when the water is high. These burrows can damage the wetlands and make it hard for native plants to grow. Draining the water also revealed Burmese pythons. These snakes can grow very long, up to 20 feet. They hide in the thick grass or under the mud when water levels are normal. But when the water is gone, their hiding places are exposed. Scientists can then find them more easily. If the swamp can reveal its hidden invaders when the water drops, how does it fight back and begin to recover? Stay tuned for more. Life, death, and restoration in the mud. When the water is very low, another problem appears. Predators gather in small holes left in the swamp. Hundreds of alligators can be trapped in a space the size of a swimming pool. They fight over fish and show behaviors that are usually hidden underwater. Birds like wood storks and great egrets also come to feed. It is a scene of chaos, but it also lets scientists study animals in ways they normally cannot. The mud itself can be dangerous. Over many years, farms have put fertilizer on the land. The mud at the bottom of the wetlands has collected some of this fertilizer. One of the main chemicals is phosphorus. When the wetland is drained, the mud is exposed to air. This can release phosphorus into the water. When the water returns, the phosphorus can cause algae blooms. These blooms are very bad. They remove oxygen from the water, and fish can die in huge numbers. Events like this happened in 2021 at Piney Point, where hundreds of millions of gallons of water had to be released to prevent flooding. Other invasive creatures are also a problem. Apple snails, which are much bigger than normal garden snails, eat plants and lay many eggs. They carry a parasite called rat lungworm that can make humans sick. When the wetlands are drained, the pink egg clusters of these snails can be seen stuck to dead plants. They are everywhere, and it shows that invasive species are spreading even into protected areas. Despite all these problems, there is hope. When scientists control the water and drain it carefully, they see that native plants can grow back from old seeds buried in the mud. Small creatures like crayfish and grass shrimp also return. These tiny animals are very important because they are the base of the food chain. If they survive, they support birds, fish, and larger predators. Scientists are using what they learn from drawdowns to manage water more carefully. They are mapping where pythons and armored catfish hide and figuring out how to reduce the number of animals that die during maintenance. The Everglades is a tough and complicated place. It shows us that nature can recover if humans give it a chance. Every time the wetlands are drained for study or repair, scientists get a chance to see the truth. If invasive animals keep spreading every time we drain the swamp, is it too late to save the real Florida? Only careful science and constant management can answer that. What do you think about the threat to Everglades? Share your thoughts in the comments section below. Thank you for joining us as we uncovered the hidden world beneath Florida's Everglades and the astonishing invaders lurking in the mud. If this deep dive gave you a new understanding of the swamp's secret battles, don't forget to like and subscribe. Click the next video on your screen to explore more shocking discoveries. See you there.